as you can see that we have to prove that a root of 3 is irrational. So to do that, we would assume a contradictory method. We will suppose that root 3 were rational. Root 3 were rational, and this is the proof. Wait a second. This is the proof that root 3 is irrational. So we have assumed that root 3 were rational. Then there would exist positive integers a and b with root 3 equals a divided by b. So there you go, root 3 equals to a divided by b, and a and b are positive integers. A and b belongs to z plus. Okay, now we have to now assume a set S, and I'll define the set S. Set S is equal to k root 3 such that k and k root 3 are positive integers. Positive integers. And there is the set. Now we can clearly see that this set S is non-empty. Because, let me change the color real quick. Because as you can clearly see that A is equal to B root 3, and then that goes with the condition of this set. So this set is clearly non-empty. Alright, so let us now assume that the set S has a smallest element. S is equal to, this is small s is equal to t root 3. So this is the smallest element of set S. This is capital S. Right, so this is the smallest element of set S. Now we'll define phi. I'm sorry, this is phi. Now phi is defined as s root 3 minus s. This is phi, which is equal to s root 3. No, I'm sorry. This is small s root 3 minus t root 3, which is root 3 into s minus t. Now bear in mind, this is the smallest element of the set S, and this is a true condition. This is also a true condition. This is what we have assumed to be true. Now because small s root 3 equals to 3t and s are both integers, then we can also say this thing also implies that s root 3 minus s, small s root 3 minus s equals to s minus t root 3 should also be an integer. This thing also should be an integer. This thing right here, or you can write it as this thing also should be an integer. Furthermore, this integer is positive because s root 3 minus s is equal to s into root 3 minus 1, and we can clearly say that root 3 is greater than 1. Now if you assume that we don't know the value of root 3, how come you know it? So there is a method. We'll have to know that under root of 1 is 1, alright, and under root of 4 is equal to 2. So under root of 3 would lie in between. Under root of 3 would lie in between root of 1 and root of 4. So this is how we're able to say that root 3 is greater than 1 and less than 2. Alright, so that is why this is a positive integer. Now this positive integer is less than s. This positive integer is less than small s because s is equal to t root 3, and this is small s, this is small s. Small s is equal to t root 3, and small s root 3 is equal to 3t, and we can clearly say that root 3 is less than 3. Now this contradicts this thing right here, this thing contradicts the choice of s that we chose as the smallest element of set S, and hence we assume hence our assumption that root 3 were rational was false. This assumption is not true. This assumption is false, and hence we have proved that root of 3 is irrational. So basically what we have done is that we have assumed a smallest element in a set, but we have found an element which is smaller than the smallest element. So this is what contradicts. So the smallest element is not s, there is another smaller element which is s minus t into root 3. This s minus t multiplied by root 3. So we are contradicting our assumption, and hence root 3 is rational was our assumption, but since our assumption is false, then we can clearly say that root of 3 is irrational. Thank you for watching.